Hello guys, welcome to my YouTube channel Good Night. Today we'll be discussing the problem Towers of Hanoi. So as the name suggests, we will be given three towers in the problem and n number of discs are placed over tower A starting from the largest at the bottom to the smallest on the top. Now the aim or objective of the problem is that we need to move the discs from tower A to tower C. So it might look pretty easy, but we have two rules that we need to follow while solving this problem. That is, we can move only one disk at a time. So as the original problem suggests, the disks are so heavy that we can only lift one disk at a time. And the second one is that we cannot place a larger disk over a smaller one like this. Suppose we have a disk like this. We cannot place a larger disk over like this. These are the rules and the main objective of the problem. Now let's look at a small example of two disks. A, B, and C are the towers. Tower A, Tower B, and Tower C. Let's assume there are only two disks. This is disk 1 and this is disk 2. Now we will be moving the disk 1 from A to B and the disk 2 from A to C. There won't be here. And now we'll be moving the disk 1 from B to C. Now we have done the problem. This might be looking easy in the case of only two disks. Now let's look at a problem more complex, that is if there are three disks. You might be wondering, it was so easy in the case of two disks. How could be so complex in case of three disks? Now just look at it. Now if you want to move all the disks to disk C, tower C, first we need to move the disk 1 from tower A to tower C. Now the second one from tower A to tower B. Okay. Now we'll be moving the disk 1 from tower C to tower B. Next we'll be moving the disk 3 from tower A to tower C. Now we'll be moving the disk 1 from tower A to tower B, from tower B to tower A. This is disk 1, this is disk 2, and this is disk 3. Next we'll be moving the disk 2 from tower B to tower C. And the final step will be moving disk 1 from tower A to tower C. As you've seen, in case of only the number of disks being 2, there were only 2 steps. But as the number of disks increased by only 1, the number of steps increased rapidly. So this becomes complex even if you go to 9 equal to 4. So how do we solve this? There is a generalized solution that if we have n number of disks on the tower A, first we need to move n minus 1 disks on the top, accepting the disk at the bottom and moving these n minus 1 number of disks to tower B. So these are n minus 1 disks. And then moving the disk n from tower A to tower C, and then moving these n minus 1 disks to tower C from tower B. But as I mentioned in the rules, they said only that we can only move one disk at a time. Then how can we move n minus 1 disks? So it's not about the number of disks, it's about the this suggests that when we have n disks and we need to move n minus 1, the next time, let's suppose we have 5 disks. Now when n equal to 5, n minus 1 becomes 4. So the next time n becomes 4, then n minus 1 becomes 3. And the other next time n becomes 3, n minus 1 becomes 2. And then n becomes 2, n minus 1 becomes 1. And the final time n becomes 1, n minus 1 becomes 0. So this is the last condition. So we will be moving the disk n equal to 1, the top one, from A to C directly. Okay, now we don't have any other disk, so we have done that. Then let's get back to the case where n equals 2. Okay, we have two disks, only two disks. Then what would we do? We will be moving the top disk to B and the bottom disk to C, and again the top disk to C. Okay, like that number of uh, the number of disks can be moved slowly using the help of tower B. But if you go to a normal explanation, it will take a long time to explain it for number of disks being 5. So let's write the code. The generalized code would be, I will be writing this code in Python. It can be applied in any other language also. The process is same, and I will be using recursion here. So let's create a definition TOH, which takes the arguments n, the total number of disks, and the from tower. From which tower do you want to move the disks, and the to tower, to which tower you want to move, and the auxiliary tower, the tower which will be you will be using to move the disks from A to C, or the from tower to the to tower. Okay, first we need to check if the number of disks equals 0. Then we won't do anything, we'll just return. We won't return anything. We will get back to the previous stage. Okay, now we'll be moving, as suggested in the explanation, we'll be moving n minus 1 disks from the from tower to the auxiliary tower, not the to tower, to the auxiliary tower using the to tower. Okay, as I have explained here, we will be moving n minus 1 from A to B. B is the auxiliary tower here. Okay, now next we will be printing it here, that assume it to be a step we will be following. Move disk n from tower to tower. So what this line suggests is that, okay, what this line suggests is that we will be moving the disk n, this is the last disk, from the from tower, that is A, to the to tower C. As I have mentioned, we'll be moving the n minus 1 disk to B and the nth disk to C, and then again we will be calling the function to h of n minus 1 from, sorry, we'll be moving it from the auxiliary tower to the to tower using the from tower. So this will be a generalized solution for every case where n can be any number. Now let's call the function. Let's take the input equal to int of input of enter number of disks, and we'll be calling the function toh of a is the number of disks. We'll be moving it from tower A to tower C using tower B. So this would be the final solution. Now as you can see, okay, now when we tag for n equal to 3, the input being 3 ACB, the arguments will be n equal to 3, and the from will be A, 2 will be C, and the auxiliary will be B. Now we will be checking the condition n is 0, no it's false. So we'll continue to the next step where we'll be calling a new stack frame, n equals 2 from A to B using the CA as auxiliary. Now again we'll be checking for n equal to 0, it's false. So we'll be calling a new stack frame where n is 1, and from A to C using B. Please don't confuse yourselves about the tower names here. First time we'll be calling from and to be A, and C using the B. Now the second time we will be moving from A to B. Okay. The next time again when n is 2, we will be calling this step n becomes n minus 1 is 1. So the next stack frame n will be 1, the from will be A, and the 2 will be C, and the auxiliary will be B again. Okay. Now this time when we check n is 0, no. When we go from n minus 1, it goes for n equals 0, which is false at this condition, and it will return back to the stack frame where n is 0, and sorry, n is 1. Now we'll be printing move disk 1 from A to C, which is the exact step from the explanation given before. You can go back and watch the video again. Now we will be doing the next step where n minus 1, then n is equal to 0. This condition becomes true, and we will be returning to the stack frame where n is 1. Now this stack frame where n equal to 1 has completed. So this will be printed, and we'll be returning to the stack frame where n is equal to 2, and then we'll be printing this step, that is move disk 2 from A to B. Okay, we'll be moving the second disk from A to B. It's the same step as I have illustrated in the explanation before. Now the next step will be there will be another stack frame where n is 2, and sorry, n is 1, and the from will be the auxiliary tower here. What's the auxiliary tower here? It's C. So from C to the what is the 2 here? Here 2 will be B. Sorry, using the auxiliary as B. Yeah. Now we'll be printing move disk 1 from C to B, and the steps continue. When we return back, we'll be going back to the stack frame when n equal to 3, and we will call it will print here this step, and we will again call from n is equal to 2, and these steps will repeat. So it's a complex problem to explain, but I think you will be getting the idea of this problem. So this is the solution for the problem Towers of Hanoi. I hope that you enjoyed the video. Please like, share, and subscribe for daily programming videos. Not daily, but regular programming videos. Thank you.